Okay, so we are what is the sample test day? And we are doing problem number 76, a geometric sequence. We know the fourth term is 9.56, the seventh term is 30.375, and we want to know what the 12th term is. What does a geometric sequence mean? We get from term to term by multiplying, by the same thing. So, in order to get from, this is the fourth term, and this is the seventh term. In order to get from here to here, I multiply by something. And then I multiply by it again, and then I multiply it by again, and I end up here. So if I take my 9 and multiply it by something 3 times, times r, times r, times r, I should end up at 30.375. Does that make sense to everybody? So can I figure out what r is? Yes. So r cubed is 30.375 divided by 9. So I need the cube root, oops, of 30.375 divided by 9. Oh gosh, did you get 1.5? That's nice. Is that okay with everyone? Now, I want the 12th term. Now, there are a couple of ways that you can do this, but remember what that means is somewhere out here is the 12th term, and you would have to keep multiplying by 1.5. You just have to figure out how many times you need to multiply. So what do you think? Yeah. We're going from the 7th term to the 12th term. Then we need to multiply 5 times. So if we take 30.375 and we multiply it 5 times by 1.5, we should end up where we want to be. $230.660. Looks like D is the answer. Is that okay with everyone? What if the sequence had been arithmetic instead of geometric? Then we would add, instead of multiply by something, we would add something. Perfect. All right, 77. The table presents values. Cubic regression is used. What is the value of f4? Okay, so we're going to do a cubic regression, and then we're going to use our Y button and plug in 4. That's all. It's that easy. So go ahead, do a cubic regression. So everybody remember, we go to stat edit. 1, 3, 4, 7, 8. But it says what is the value predicted by the model? Remember, the model will not necessarily be the exact data points. Hopefully it's close. Let's see. No, I lost my train of thought. This is how we get residuals. Remember the difference between the actual data point and what the model predicts. Bryce saying, what was that about, Bryce? Did something cool happen? 61.382. Okay, so remember, back to Julia's question, the actual data is in the table. When you write a model, when you write an equation for that data, it isn't going to fit the data points perfectly, and that difference is called the residuals. All right, perfect. Everybody good with that one? All right, 78. Complex number has rectangular coordinates, -1, 3. So that's x and y. Rectangular, x and y. Which of the following is one way to express the complex number using its polar coordinates or theta? Would everybody agree that -1, 3 looks like that when I graph it? Luke, you okay, sweetie?
Yeah.
Need to go see the nurse? You sure? Okay. Now, this is R, right? What's R? Square root of 10. This is theta. But I'll need my calculator to find that guy right there. So, okay, so second tangent 3. This angle is 1.249. That little angle right there. So how will I find my actual theta? Minus, yep, that's exactly right, beautiful. So 1.893. So we should have root 10 cosine 1.893 plus I root 10 sine 1.893. Remember, the I always goes with the sign. Is that one of our answers, I hope? Looks like C. You good? Okay, all right. Which of the following graphs could represent these data in a semi-log plot where the vertical axis is logarithmically scaled? All right, now guys, first of all, if the vertical axis is going to be logarithmically scaled, tell me about the labels on the vertical axis. They're going to be powers of 10. So I'm not even going to really spend much time on this problem because the only one that has powers of 10 on the vertical scale is A. And if I look at just a couple of points, doesn't it make sense that 1 is 25? Remember, those hash marks on your logarithmic plot, these hash marks, so this is 10, this is 100. So the first hash mark here is 20, and then 30, 40, 50, 60, 70. They're counting by tens in here. And here they're counting by hundreds. So A is your answer. All right, that's easy. Okay. I think these are so fun. You guys don't look very excited. The points 3, 4, and 5, 8. So there's 3, 4. There's 5. We've got some kind of cosine curve, and those are consecutive minimum and maximum values. So something like that's happening. Can we find our midline? If that's the min and that's the max, won't the midline be right in the middle? So it'll be 6. And then this represents the amplitude. So that is 2. So A has to be 2. What am I looking for? B and D. Oh, I'm not even looking for A, sorry. D I got, D is 6. Now, B has to do with the period. From minimum to maximum, that's a distance x-wise of 2, which means our period has to be 4. So 2 pi divided by B is 4. So B has to be pi over 2. So B is pi over 2 and D is 6. Good, good, good. Anybody have a question about that? Oh, try to stay awake. Here we go. 81. What's going on? Okay, so I have my calculator, which is good. I want to find the point of intersection of this equation and this one. And I'm only going 0 to pi over 2. So that is my x min and max. So my window, my x min and max is just going to be that. How do I put that in my calculator? How do I put those 2 equations in? I know how to put that one in. How do I put this in on my calculator? I don't have a cosecant button. Literally, 1 divided by sine 1.8x. 1 divided by sine is the cosecant. Alright, and my window is 0 to pi over 2. Xander?
On the AP test, it's gonna, like, what is the formation, like, that it goes in? Is it the multiple choice, like, multiple choice?
Oh, what order does it go
Yeah,
in?
you know.
No, but I will try to find that out. I think it's the order that the test, the practice test have been designed. That's not the order we've done it, but I think it's no calculator, multiple choice. Calculator, multiple choice. No calculator and calculator for response, but they might do all the no calculator at once. I'll see if I can figure it out. I'll just ask somebody who's taken the calculus exam, Mr. Shetty would know. Yeah, this is probably the same. Good question, great question. Does it matter to you?
No, I just, like, kinda, like, know that.
So you know when going in? Oh, shoot. All right, I'm finding, it looks like I've got 2 points of intersection. What about you? I've got one that is 0.241. So I think the answer is C. How's that? Did you guys get that too? Point of intersection? Tell me how you're gonna do number 82. Graph it, okay, we can do that. You'll need to change your window, because now we're between 0 and 120. All right, and then what, Julia, once we get the equation graph?
Also graph just y equals 160.
you say 115?
Yeah.
All right, now, are you looking for the point of intersection? Is that what we're looking for? No, what are we trying to figure out? How does the graph behave? And look at the answers. Aren't we really concerned about whether it's going up or down and what its concavity is? So, I guess you could graph that other one if you wanted. I'm just gonna graph this first one. And I'm gonna hit trace. And I'm gonna just follow my cursor until I get to 115. And when I get to 115, or very close to it, I notice that my curve at that point is kind of doing this. So what is happening? It is decreasing at an increasing rate, because isn't it concave up there? Now how I did that, I just hit trace and made my cursor go till I got to 115. So that was the part of the curve I was looking at. And at that point, I'm still decreasing, but it's concave up. Perfect. All right, we're almost done. 83. What do you think for 83? Which of the following is the domain of F inverse? Okay, now wait a second. The domain of F inverse will be the range of F. Would you agree with that? Because what do inverses do? Switch X and Y. So if I want to know about the X's of the inverse, I need to look at the Y's of the original. Okay, so tell me, what are the Y's of the original? The Y's of the original are 3 to 10. So what are the X's of the inverse? 3 to 10. 3 to 10. P of 3 is 6. So 6 equals ln 3c squared. They tell me this equals 6 if I plug in 3 and I'm plugging it in for t. And my job is to find 3 10. Okay, who's got an idea? Someone talk. Here's my function. I can't really plug in 10 until I know C. Can I figure out C? Yes. How do I do that? I gotta use my properties of logarithms, which some of you did not do a very good job with, and you need to know. What do you suggest we do here? We gotta solve for C. So we could do e to the 6th equals 3c squared. Remember, the base on that's e. So we can log roll it. And then divide by 3. And then square root. Now that is not going to be the answer to the question. That's going to be C. So, e to the 6th divided by 3. Square root. What did you get for E, or in C? 11.596. Now, someone asked me yesterday, and maybe we haven't talked about it enough. If you're going to need that number again, store it. Just hit STO, and then give it a name, like letter A. And now that number is stored and your calculator is A. And then when you want to use it again, you can just recall it back out as A. Or you can keep the number, the decimal, but keep a lot of decimal places, okay? Don't round it off, because you're gonna be using that number to find P of 10. So P of 10 will be ln 10c squared. So I'm just gonna take my c and square it times 10. I'm gonna ln that. I got 7.204. Hopefully that's an answer. All right, how about 85? What are we gonna do? Do an exponential regression, absolutely. You know how to do that, we can do that pretty easily. Stat, edit. 0. All right. I have my exponential. What do I do now? Get 5, all right, so I'll plug in 5, so y of 5. Yeah, right, y. 5. Okay, then what? By the way, for my y of 5, I got 0.8898904, is that what you got? Now it says the residual is 0.512. How do you find the residual? What's our little formula? The residual is actual. Good, Quinn. Actual minus the model. Now, this is the model right here. This is what we got when we plugged it into our model. So that's 0.8898. I do not know what this is, but the residual is 0.512. So can I figure it out?
You should add those.
Yeah, I'm just gonna add that to 0.512, and I got 1.402.
Yeah.
Perfect. 2 more, and we're done. Students taking K, turned in. E of T is measured in units per minute. T is measured in minutes. At what value of T does the rate of exams being turned in reach its maximum? Now, the first time I read this, I wasn't careful, and I said, oh, that's easy. The maximum is going to happen when you add 9.1 to 12.63. Won't that be the highest point on the graph? It will, but that isn't the maximum T value, that's the maximum E of T value. when are we going to get to our maximum? Tell me what you know about the sine of 0.18 if we're gonna be at the maximum. When is the sine at its maximum? Pi over 2. Pi over 2. So whatever this is, 0.18t has to be pi over 2. Because that's when sine is going to be the biggest it can be. Never bigger than 1. And it's 1 at pi over 2. So t is going to be pi divided by 2 divided by 0.18. So 8.727. Okay. And then 87, we had one of these before and it's confusing. If you don't stop and take the time to write down what your points represent. The function models the x-coordinate as a function of seconds. So your points are going to be seconds and x-coordinate. That's what your points look like. So when it says at time 0, at time t equals 0, the plane is at the point 5, 0, so that means your point is actually going to be 0, 5, because the seconds are 0 and the x-coordinate is 5. At 60 seconds, it's run around 6 times, or 10 times. So that means each revolution, or each period, is 6 seconds. So when is it back at 5 again? It's back at 5 again at 6 seconds. Now, remember, this is a periodic thing. So you've got a point at 0, 5, and then a point at 6, 5. Those are the maximums. When is the minimum going to happen? At 3. So at time 3, where is my thing going to be? At -5? Its x is going to be -5? Halfway around the circle? Is that enough to write the equation? I don't know. It's a cosine equation. It has no phase shift. What's its period? B is pi over 3. So I think the answer is A. Again, what makes that tricky is, in the actual ordered pairs, the y value is the x-coordinate of the point indication. All right, my friends. Here is our next task. I know you are super excited.